Precalc Chapter 9, Section 1, and we're going to split this into two parts, Part A and Part B. Part A is just going to deal with the introduction of the chapter and circles. So this is just Part A. So we're going to recognize a conic as an intersection of the plane and a double nape cone, and then write equations of circles. So a conic section is an intersection of a plane and a double nape cone. So a double nape cone is when you have the two cones meeting at this point here. And so then if you intersect it with a plane, so if you cut through it with a flat surface, the different shapes you would have. So you can see if we have kind of a, we cut through, so we can draw a three-dimensional shape here of the plane. So this flat surface would give us this parabola on it. We cut through the cone here, we get a circle. And if we put that at an angle, we get the ellipse. And then if we go more vertical through both of them, then you get the hyperbolas. And so we'll talk about those throughout the chapter. So if a plane goes through the vertex, the result is a degenerate conic. So if the plane goes through this vertex, this where the two cones intersect, you get degenerate. So you can see how if the plane lines right here, you can see how it's not just a single point. You actually get the line, and then you can actually get a single point if you just come through straight through the point. The general equation for these is expanded like this. Here's your general equation, nice and long. So you have your x squared and you have a y squared, or sometimes you'll have a y squared for these. And you have all the other terms as well, and usually it equals 0. It's the general form for these equations. You have a locus, which is just a collection of points satisfying a geometric property. So a locus is a definition for the shape based upon the points of the shape. So a circle, a locus for the circle, is the set of all points in a plane equidistant from the center. So all the points have the same distance from a center point called HK. So our center is HK, then points x, y are on the circle. The circle has a standard form, x minus h squared plus y minus k squared equals r squared. And that should look familiar to you. We've seen that similar form with our shifting, our horizontal and vertical shifting. And then we have a center, if the center is at the origin, it's just x squared plus y squared equals r squared. And so you notice how the h moves our center point right h units, or opposite the sign. And then our k moves the circle up or down k units. And this is as well opposite the sign. That's why we have the minus here. So example, point 1, -2 is on the circle. So that means that this is like an x, y value on the circle. And then the center is hk is -3, 5. And so we want to write the equation of this. Standard form for x minus h squared plus y minus k the quantity squared equals r squared. So we know our h value is -3, so I can plug in h, I can plug in k, but I don't know r. So what I can do is I can plug in an x and y to then solve for r. So if I do that, our x is 1 minus a -3 squared plus our y is -2 minus our k value, which is 5 squared equals r squared. So you're getting 4 squared or 16 plus -7 squared, which is 49. So we're at 65 equals r squared. So then our radius is the square root of 65. If we want to do the general equation, it's just going to be x plus 3 squared plus y minus 5 squared equals r squared, which is 65. So that would be the equation of it, knowing that our radius is square root 65. So we want to sketch this equation. It's in general form. We want to first put it into standard form, which this is the interesting thing about this beginning of this chapter, which makes it a little more difficult, is we have to put this in a standard form. We have to break apart our x's and our y's. And we want to write this. I'm actually going to move the 40 to the other side, so subtract 40 both sides. we want to break this up so you have your quantity squared. So these are perfect squares. So what we want to do is we actually want to complete the square. So we are going to complete the squares of the x's, and we will complete the squares of the y's, both in one problem. So recall that we have to take our b value, negative 14, take half of that, which is negative 7, so negative 14 divided by 2, which is negative 7, and I square that, so 49. That's what number goes here. Do the same thing here. Half of 8 is 4, 4 squared is 16. Now if I'm adding 49 and 16 to this side, I need to also add it to the other side. So we're adding 65, so let's add 65 over here. So now I can take this portion and I can rewrite it as x minus 7 the quantity squared, plus take the y's, write it as a perfect square, y plus 4 squared equals negative 40 plus 65, so 25. And so now I have it in standard form. So we have our hk value, which is going to be 7, 4. And we have our radius, which is the square root of 25 or 5. So that helps us. So now we can sketch a graph of it. Let's first plot our center. So there's 7, 4. And then our radius is 5. So go 5 in every direction. So I usually the vertical or horizontal. It could be out here, and then you just draw the best you can a circle going through those points. So one more example here is to find the x and y intercepts of this, and this is a good review just to know that if we have the x-intercept, that means that the y equals 0. So you can plug 0 in for y. And then evaluate for x. Just solve for x. So negative 1 squared is 1, subtracted to both sides, we get 9. So now we want to square root both sides to get x plus 2 equals plus or minus 3. Then x equals subtract 2 to both sides. So positive 3 minus 2 is 1, or negative 3 minus 2 is negative 5. For the y-intercept, we can do that again. For the y-intercept, we're going to let x equal 0. So we're going to get 2 squared plus y minus 1 squared equals 10. So we have 4, subtract 4 gives us 6 over here. And y minus 1 squared. So we can square root both sides and get y minus 1 equals plus or minus root 6. So then add 1, so y is 1 plus or minus root 6. So those are 3 examples, similar to ones you're going to deal with in the homework on circles.